So I come with multiple laptops because that's generally how I roll. I'll show you this little video. You've probably seen it on the website, but I think it's a good segue into the talk. These are the quality control inspectors in Antarctica. They're making sure my drone is secure and everything is tight. They were adorable. We were supposed to keep 5 meters away from them. Nobody gave them that memo, so they just come right up to you. This is the Argentinian research station that we got to. Oh, sorry, I should probably talk into the mic a bit, right? Sorry about that. We got to visit a couple of research stations, and this is the price of admission to Antarctica. So if you can handle 3 days of 12-meter seas and 80-kilometer-hour winds, you can make it there and back. But so I'll just flip this around. There it is. So what I thought I'd do is, instead of just giving you a PowerPoint presentation with a bunch of text, I thought I'd show you the actual research and the data that I've been collecting and what drone data looks like. I prefer the term UAS, or unmanned aerial system, but let's use drones for the time being. Usually drones are, shot out of the sky by airplanes, so I don't like my drones being shot out of the sky. So what we're looking at here is, well, welcome to Antarctica. So this is a 3D model that's created by combining a series of overlapping two-dimensional images captured by a drone, and then you mosaic them together, and the software does this magical thing called structure from motion, and where it actually correlates overlapping pixels and extracts three-dimensional information from that, based on something called parallax, which we all do. We have two eyeballs, and we're always looking at the world from two slightly different perspectives. That's essentially all you need to be able to have the computer tell the Z dimension rather than just X and Y from a flat two-dimensional image. Plus the fact that all these images are geotagged, so there's a GPS on board the UAV, so we know where that picture was taken precisely, plus or minus 5 meters or so. And then we can actually create realistic, accurately positioned 3D models from the overlapping photos. The photos themselves aren't terribly interesting. This is one of the photos. It's just more or less the camera pointing straight down at the ground, so that doesn't look very impressive. But once you stitch all those photos together, you can give this 3D model a spin, right? So we can look at the ground, and it's really, really detailed, right? So we're down to a couple of centimeters per pixel, right? So we can look at rocks, we can look at all sorts of different structures. We can even look at penguins. There's a bunch of penguins in this shot, but the penguins kind of look like rocks because they're black and white, the rocks are black and gray. So it's sometimes hard to tell. I'll just zoom this out a little bit to give you a larger perspective of the model. So that kind of gives you an idea of what was captured. There's some gaps here and there. That's, the correlation isn't perfect everywhere. So that's just a regular color camera that was mounted on the drone. Let me show you another example, and here I'll just show you the flat version. The software takes a couple of seconds to load as fast. I got the fastest gaming laptop I could find. There's not a single game on this laptop, I'll assure you, so I'm just trying to do all this 3D modeling stuff, so it crunches for a bit. What I did in Antarctica was I went there with the idea of taking what are regular off-the-shelf sensors that are initially designed for agricultural purposes. So they're used to detect crops, health, chlorophyll content, biomass, and I wanted to see what they can do in an environment like Antarctica. So what would be their function, or what could we use them for in an unconventional way? So this is an example of what's called an orthomosaic. So let me see if I can turn on, yeah. So this is all the photos kind of stitched together and to make a nice flat, accurate map. And what we can see in this photo is the colors are a little bit different than what you're used to, because we're looking at 5 spectral bands, meaning 5 wavelengths of light smushed together. So we've got a separate image for red, green, blue, and then near infrared and mid infrared. All right, so that's called multispectral imaging. And that's what these cameras can do. So I'll just step away here. The green and the pink on there, which kind of show up, that's algae that's growing on top of the glaciers. And that's an indication of the climatic conditions of the area. One of the things that we're looking at to see is, can we use multispectral drone photography to map the distribution or the change in the distribution of algae in an environment like Antarctica. You can also begin to see, I guess I can use my pointer here, these tiny little red splotches down here are people, okay? So you can kind of see people in there in the image. But penguins, forget it, right? You really can't see penguins. So let's flip over to the next data set. All right, and I'll press 0. There we go. So this looks different. This is a thermal image. So this is now taken by a camera that detects heat. Okay, so when you've got differences in temperature, you've got differences in color. So the darker, bluer tones are cold. The lighter, yellowish reds are warm. So you can begin to see that there's a bunch of little yellow dots all over the place, right? And as I zoom in, you can begin to recognize that some of those dots are bigger and some of them are smaller. So for example, the small dots over here are penguins. And the sort of chunkier dots down here are people. All right, that's good. Good, good, good. We're on the same page. Now, what are these? Seals, yeah. Right on, you guys. I wish I had a prize. Just throw like mini drones at you. And then over here, just for scale, you can see that we've got a zodiac, and that's how we made it from the ship to land, just for reference. So now with this kind of image, you can sit there and you can count penguins. It's not that hard. But I wouldn't do that, because when we were landing at this site, one of the passengers on the ship said, "Gee, I really hope we see penguins on this." And there's 14,000 of them just on this island, right? So you don't want to be sitting there counting penguins manually. But we can feed this data into a geographic information system software and just tell it to look for a specific range of colors with a certain maximum size. So you could actually very, very quickly, within a few minutes, train the software to count penguins for you, and then it'll just come up with a number, right? 482 penguins, or you can get density, or you can get whatever you're looking for. So this isn't possible from other types of remote sensing technology, so you can't do this from a satellite. Okay? You're not going to have the resolution to be able to see penguins from space. At least not with non-military technology that we have access to. It's hard to do this with aircraft. It's hard to get aircraft to Antarctica, as you can imagine. It's extremely expensive. Drones provide a much more accessible, efficient, and quick way of studying small areas. They're not really good for mapping large areas because of the limitations in battery and et cetera. So this is a feasibility study. I wanted to take our BCIT drones to Antarctica with some fancy sensors to see if we could run a feasibility study. How does it look? I'll show you this model here also from Antarctica. I'll move on to some other data sets in a second. We'll let this load. I was interested in finding out whether we could use it to map edges of glaciers. What about crevasses? Can drones see crevasses? Can it help us see structures underneath the surface that we can't see with the naked eye? So this is a model of right near the...
So as we are waiting for the electricity, can you tell me about the drones that we have at BCIT? How many drones we have, where they are, what quality they are?
Really good question. So the question is what kind of drones and how many drones we have at BCIT. This is an excellent question. I can't even answer it for you. I can tell you what we have at the Geomatics department. We have 5 drones, 2 Phantom 3 Pros, 2 3DR Solos, and an Inspire 2. So kind of a couple of small drones, 1 slightly heavier lift drones with interchangeable payloads and cameras. The LTC also has the drone zone, right? They have a workshop They have, I don't even know how many drones they have, 5 or 6. They have a fixed wing one, so for longer range type of stuff.
So the camera is installed on them, or you installing it?
Yeah, so some of them come with the camera attached. Some of them have interchangeable payloads, so we can swap out cameras, we can swap out lenses. You know, we can add
how
different.
far they go up?
Legally or operationally? Legally, we're completely capped at 120 meters above the ground. So as far as Transport Canada is concerned, that's as high as you can fly a drone. If we were to actually just take the drone up, it'll go to about 5,000 meters. So they can go very, very, very high. Yes? Yes. So the question is, do you have to comply with Transport Canada when you're in Antarctica? Not Transport Canada itself, but you're dealing with the Antarctic Treaty Organization. You're dealing with the ship operator, who was from the States, so I have to comply with FAA. And I have to comply with Environment Canada, so there's a 3-step permission process, because you can't fly drones in Antarctica unless you have a permission.
So are you flying it, are you on land, or can you do it from the ship?
I've done it on both. So most of the sorties or the missions that I did were from land. We actually took the Zodiac, you know, and I was on terra firma. But I did do a flight from the Zodiac a couple of times as well. That's scary.
How long was your expedition?
2.5 weeks.
Oh.
Yeah.
That coal in the battery, you mentioned that was becoming an issue.
Okay, so I was in Antarctica in March, which is at the end of their summer, during a time when it was colder in Vancouver than it was there. So I can't answer your question. If you go in there, obviously in the middle of winter towards the continental central part of the continent, it gets to, you know, -80. But I was flying at -5. So the batteries on the drones that I had were self-heating, so they run a current through the battery, so it keeps them at an optimal temperature. Yeah. I'll just have to.
Are there any applications for search and rescue? I don't know if we get lost in Antarctica, but
yeah, no, that's a really good question. They absolutely do have drones with sort of emergency packs that can be released to an individual. If you're in the water, you don't last more than, you know, a couple of minutes, so that there's no point. But I mean, in places like Australia, they do drop flotation devices that are good for 2 people from a single deployment. But one of the main things is these expedition ships want to do camping on glaciers, but they don't know where the crevasses are. So they can send a drone out and do survey an area where they find a camp, bring the drone back. Within half an hour, they can have a map of the crevasse structures underneath the snow surface. So they can say, okay, we're going to avoid this area, here's a safe place to camp. Or even send the drone ahead of the ship a couple of kilometers to see what the ice conditions are like. Yeah, lots of applications.
So first question is, did you get seasick?
Oh, hell yeah. Yeah.
And the other question is, and I think I chatted with you the last time you presented at this point.
Yeah,
but,
right.
Were there any mechanical challenges that surprised you that our department might be able to get involved with?
There wasn't a single time I flew when something didn't go right. So every time something went wrong. So lots of opportunities. This is one of the reasons why I wanted to go to that place and challenge the gear and myself to see, you know, what's it like in a harsh environment. Definitely so much learning going on in terms of how the equipment was mounted on the drone, and you know, what are some of the opportunities to enhance that. So I've already come back with a bunch of knowledge about how to fix those problems.
Right, so are there potential projects for students, I guess, in mechanical engineering?
Absolutely.
So we should talk.
Yes, yeah. So to your question, oh, go ahead, yeah.
Go ahead.
Well, one of the things I'm proposing, and this is, you're probably the first group to really hear this idea is I have an idea to create this drone center of excellence at BCIT, which would centralize all of our UAV activities, because there are departments that are using this technology, not realizing that another department has done this already. Permissions, for example, right now we have an application into Transport Canada to allow us to fly BCIT drones all over BC. So if this gets approved, this would open up the door to research, marketing, for example, applications. We would be able to, within rules and guidelines, but we'd have a free reign to fly BCIT drones anywhere in BC.
So I don't know the resolution of the camera that you use,
Yep.
but how you can make sure that 1 point means, I don't know, 1 or how many penguins or seals?
So the resolution of the camera, the one that I was showing you is 24 megapixel, right? So it depends on focal length and how high you fly. That'll govern the pixel size. So I was getting 1.2 centimeters per pixel. So that's enough. I mean, if you've got sort of 10 pixels for an object, you can tell what it is pretty easily.
I was wondering, in terms of interpreting tightly packed penguins
Yep.
versus a seal, does the software have trouble with that? Or?
Not at all. No issues. The only trouble is when the penguins are moving significantly between frames. Right? So if there's movement from one frame to another, the software is not going to correlate those points as being the same. So the ones that are kind of, penguins don't move very fast, right? They're not gonna, like, so let's say you might miss a certain percentage because of movement for sure. Yeah. Yeah.
Do you have a date for the next expedition?
So I really started this whole drone thing about a year ago, and I've been involved in about 10 projects since then. 4 or 5 of them since February. So there's always stuff happening. I just flew Vishon Creek here. I flew the Circus site. We were on Bowen Island doing a collaborative project with students from ecological restoration and building and architectural sciences. So I'm all about bringing people on board with this, forensics, civil engineering, anybody who's interested, or could even facilities and campus development. We're trying to, there's a proposal that we have right now, some money to see if we could introduce that as a tool to them mapping the campus and keeping track of what's going on campus. So there's tons of opportunity, and I welcome all of your input. I want to bring everybody in on this. Yeah.
Eric, just a question in regards to flying the drones. Now, you said you have an application out to Transport Canada.
Yep.
Like everyday consumers can fly these drones anywhere, I guess. What's stopping us from sort of flying this? Are there regulations where you can fly them or where you cannot?
Yeah, there's very strict regulations where you can fly and where you cannot. Yeah, so they're based on drone weight. So let's say you go to London Drugs, you buy that white DJI Phantom, which weighs 1.2, 1.3 kilo. You can't fly that anywhere where it's a built-up area, like first and foremost. So anywhere where there is a house, anything more than a farmstead, like a barn or a house, you can't fly it. Period. So all these people that you see flying drones all over parks and down the beach, completely illegal.
Oh.
Right? Yeah.
Wow.
So all that stuff is regulated very heavily, and there's fines. There's fines up to $25,000 for illegally flying drones.
Oh, wow. Okay.
And so Transport Canada is getting very serious about that recently. The police now have a little cheat sheet because they don't know if you're flying your drone legally or not. But now Transport Canada is giving this little cheat sheet that says, okay, is the drone within 30 meters or 70 meters from a building? Yeah, illegal. Is it being used for anything but recreational purposes? If it's for commercial purposes, you need a Transport Canada approval, right? So they can ask us a few simple questions. Show me your Transport Canada application. I don't have one. Illegal. So I would say 90% of people flying their drones illegally, and they don't even know it.
Okay.
But again, ignorance isn't really to get you very far.
Perfect. Thank you.
Sorry. One last question for Eric.
have a question.
Yeah.
Have you considered using this for like the exploration of like very inaccessible locations, like potentially like deep sea or like Mars or like inaccessible jungle locations?
Next expeditions to Mars. Yeah, they're going to be flying drones on Mars pretty soon. That's already happening. It's not me. Deep sea is very, very hard. I've seen water penetration up to a few meters, but that's about it. Then you don't have enough light to see that deep. The other restriction, mentioning regulations, is that you have to keep the drone within line of sight. So you can only be 500 meters away from the drone. Good morning.
Like long range.
So long range requires different approvals. So you can fly long range, you just need more permissions. Yeah. Well, I guess that's it.
Yeah.
Thank you.